A uniform ladder of length L rests against a smooth vertical wall. The mass of the ladder is m, and the coefficient of static friction between the ladder and the ground is mu. The minimum angle at which the ladder does not slip is given by. Here you have given the 5 options and you have to choose the right one. So to choose the right one, we will solve this numerical. Here I have mentioned you 5 steps. Basically, these 5 steps help you to understand this problem in a better way. So step one is the free body diagram or force diagram. Force diagram is basically the diagram in which you draw all the forces that act on an object. So let's start and try to draw all the forces that are acting on ladder. So number one is the force of gravity that is acting in the downward direction, and here I am representing it with Fg. Number two is the normal reaction force that this floor exerts on this ladder, and here I am representing it with N. Number three is the normal reaction force that this wall exerts on this ladder in the leftward direction, and here I am representing it with N prime just to distinguish it with N. And number four is the force of static friction that is acting in rightward direction, and here I am representing it with Fs. Now, these two normal reaction forces are responsible to produce torque, because these forces have a tendency to rotate this uh, body. Okay, this normal reaction force has a tendency to produce anti-clockwise torque, and as the clock is and as the torque is anti-clockwise, so it means it is positive, and this normal reaction force is responsible to produce torque in clockwise direction, means negative torque. Okay, so this is our force diagram in which we have represented all the forces. So step two is that we have to apply the first condition of equilibrium. So what is the first condition of equilibrium? The first condition of equilibrium says that sum of forces acting on a body is zero, means summation Fx. Here I am writing the first condition of equilibrium is equal to zero. Likewise, summation Fy is equal to zero. Okay, what does this term means that summation Fx is equal to zero? Basically, it means that the right forces are going to balance the left forces. So here the force that is in the right direction is Fs, that is force of static friction, and it balances the left force, that is normal reaction force, which the wall exerts on the ladder. Okay, here I'm going to substitute the value of Fs, that is mu s n. Here basically mu s is the coefficient of static friction. Okay, now we will solve this expression. Summation of y is equal to zero. It means that the upward forces balance the downward forces. Here the upward force is the normal reaction force N that the floor exerts on the ladder, and the downward force is the force of gravity. Okay, here we substitute the value of Fg, that is mg. N is equal to Fmg. So this value of N, now we will substitute this value of N in this expression, and this expression would be like mu s mg is equal to N prime. Now we will give these equations some name. Let's this is our equation 1 and this is our equation 2. And now we will apply the second condition of equilibrium, which says us that sum of torques acting on a body is zero, means anti-clockwise torque is equal to clockwise torque. Basically, torque is equal to Rf. Here this R is important because this R is the movement arm, the perpendicular distance from line of action of force and axis of rotation. So here this R is really important. You will see this. Now, firstly, we will write the anti-clockwise torque as this n prime is responsible to producing the anti-clockwise torque, means this force is responsible to producing the anti-clockwise torque. So I'm going here to write this n prime. Now, the important is moment arm, which we will consider here. Now, to find the moment arm, basically the moment arm is perpendicular to this uh, rea- reaction force. Okay, means it is someone in this direction. Okay, so what you have to do, firstly you have to consider the pivot point. We know that whenever we solve problems relevant to torque, we will consider some pivot point or some hinge point, you can say that. Okay, so this is our pivot point, and the distance between this pivot point and uh, to this point is L. Okay, so when we resolve this L into components, uh, this would be our sine component of L, means L sine theta, and this would be our cos component of L, means L cos theta. Okay, here I'm considering this big triangle. Okay, so from here, if you find moment arm, so this is the moment arm because it is the perpendicular distance from this reaction force. Okay, so here I will substitute L sine theta. Okay, is equal to, now we will write the expression for uh, clockwise torque. So as this force is responsible to produce the clockwise torque n, and what will be the moment arm in this case, that would be perpendicular to this n. And so if we consider now here we will consider this small triangle, we are going to consider this small triangle for clockwise torque. Okay, so if the distance from this point to this point is L, then the distance from this point to this point is L by 2. Okay, now we will resolve this L by 2 into components, and this is the sine component which we get, and this is the cos component, which is basically perpendicular to the normal reaction force. So this uh, is what we write here, L by 2 cos theta. Okay, now in next step we will substitute the values of n and n prime from equations 1 and 2. So substitute these values. Else, firstly we will cancel this L with this L. Okay, this L gets cancelled with this L. Now in next step we will substitute the values of n prime. Okay, sine theta n prime. So what is n prime? N prime is from equation 1, it is mu smg is equal to 1 by 2 cos theta. And what is n from equation 2? N is mg. Now mg gets cancelled from both sides, and here we left with sine theta mu s is equal to 1 by 2 cos theta. Okay, so if we solve this expression in such a way that sine theta over cos theta, if we simplify this, is equal to 1 over 2 mu s. Okay, and we know that sine theta over cos theta is equal to tan theta. So here tan theta is equal to 1 over 2 mu s, and from here if theta comes tan inverse of 1 over 2 mu s, which is the minimum angle uh, at which the ladder does not slip. So here the right option is option C. This is our right option, which you have seen uh, when we have solved this numerical. So this is your right option. Theta is equal to tan inverse 1 over